Sketch graphs of f of x equals 3 to the x and g of x equals log base 3 of x on the same xy plane. Then find the domain and range of each function. We're going to make a table of values to sketch the graph of f of x equals 3 to the x. So I'm going to pick -2, -1, 0, 1, and 2. I'm going to start at the bottom. 3 squared is 3 times 3, which is 9. 3 to the first is 3. 3 to the 0 is 1, because anything to the 0 is 1. 3 to the negative first is 1/3, and 3 to the negative second is 1/9. So plotting these points, we've got 2, 9, which is just above where the part of the xy plane we have goes, but we can move up one more value from 8 to 9. Then we've got 1, 3, 0, 1, -1, 1/3, and -2, 1/9. And we can see that this graph is very similar to the graph of y equals 2 to the x, except it's growing even more steeply as we move to the right. And then as we move to the left, it's still going to be asymptotically approaching the x-axis, but it's going to be doing so even more quickly, and it's going to be hugging the axis even more closely. So this is our graph of f of x equals 3 to the x. Now for g of x equals log base 3 of x, we have two options. We can make a table of values from scratch and sketch the graph that way. We can also use the fact that these are inverse functions and reflect our points across the line y equals x. Either way will give us our graph, and I actually want to rely on the fact that these are inverse functions. So I'm going to take each of the points on our original graph and I'm going to reflect them across this line by switching the x and y values. So instead of 0, 1, we're going to end up with 1, 0. Instead of 1, 3, we're going to have 3, 1. Instead of 2, 9, we're going to have 9, 2. Instead of -1, 1/3, we're going to have 1/3, -1. And instead of -2, 1/9, we're going to have 1/9, -2. And so we can connect these dots with a smooth curve, and we get something that looks like that. And then as we go downward, we're going to get closer and closer to the y-axis. We are asymptotically approaching the y-axis down there. Now, if you don't like this method that I used, you could also make a table of values. G of x equals log base 3 of x. If you're going to do that, you're going to want to pick values of x that are powers of 3. So, for example, 3 and 9 are powers of 3. 1 is a power of 3. And we can also have fractional powers of 3, 1/3 and 1/9. These correspond to 3 squared, 3 to the first, 3 to the 0, 3 to the negative first, 3 to the negative second. And you can plot these points. They end up being the exact same points that we've plotted here, because you'll notice that each of them is just switching the x and y values, which is the case because these are inverse functions. Now, we do also want to talk about the domain and range, because it's important to understand domains and ranges of exponential and logarithmic functions. For the exponential function, the domain is all real numbers from -infinity to infinity, and the range is only positive numbers from 0 to infinity. When we look at the logarithmic function, we know that because it's the inverse, the domain and ranges should switch, which means the domain should be from 0 to infinity, and the range should be all real numbers. And if we look at the graph, we can see that that's true. The domain is from 0 to infinity because we're always staying to the right of the y-axis. In fact, it's impossible to raise 3 to a power and end up with a negative number. That's why we will not have negative numbers or even 0 as in our domains. And then the range from negative infinity to infinity, it's easy to see that this goes down to negative infinity, but as we move to the right, because there's this arrowhead, this means we will be getting bigger and bigger. And even though we'll be growing slowly as we get bigger, because logarithms do tend to grow slowly as the value of x gets bigger, it will continually be increasing, and it will continue to grow and grow, and so it will approach infinity eventually. So our range goes from negative infinity all the way to positive infinity. These are the same domains and ranges that we saw with 2 to the x and log base 2 of x, so it doesn't matter that we're changing the base, we still have the same domains and ranges.